Our project was on arithmetic and geometric series and sequences. There are 5 formulas in this unit, 2 types, explicit and sum formulas. In the top here are the explicit formulas. The top one is the arithmetic formula, a sub n equals a sub 1 plus n minus 1 times d. Below that is the geometric explicit formula, a sub n equals a sub 1 times r to the power of n minus 1. And then there are 3 types of sum formulas. The top one on the left is the arithmetic formula, s of n equals n divided by 2 times a sub 1 plus a sub n. And below that is the geometric, s of n equals a sub 1 times 1 minus r to the power of n divided by 1 minus r. And then this third formula, sum formula on the right, is what you use for continuation problems. S equals a sub 1 divided by 1 minus r. So you don't need to memorize these formulas, but you do have to know when to identify arithmetic and geometric. So we're going to talk about how to do that. Arithmetic are sequences or series in which each number in the set is added by one number throughout, so the key word being added. Geometric is the same thing, just multiplied. So you look at a series and see how it adjusts, and you can tell whether it's adding or multiplying. And if it's adding, it's arithmetic. If it's multiplying, it's geometric. So arithmetic sums and sequences. To solve for specific terms, you would use the explicit formula, which is again that a sub n equals a sub 1 plus n minus 1 times d. And to find the total amount or the sum, use the sum formula, s of n equals n divided by 2 times a sub 1 plus a sub n. And then for geometric, which is the multiplying, you have the explicit formula down here, a sub n equals a sub 1 minus r to the power of n minus 1. And that's when you're trying to find the specific term. And then down here is the sum formula you would use for geometric, s of n equals a sub 1 times 1 minus r to the power of n divided by 1 minus r. So I'm going to take a look at some example problems. The first one is not in there, or is a sum problem. So the problem is given to you up here. You have the sum sign. At the top it's the number 9, then below it k equals 4, and then the formula k squared minus k plus 1. So the first thing you need to do is find out what a sub 1 is. So you plug in 4 for k because it tells you below that k equals 4. So 4 squared minus 4 again, which you plug in for k, plus 1, and you get 13. So next in these problems you have to figure out whether it's arithmetic or geometric or neither. So how to do that is we're going to plug in, do the same thing, but for 5, 6, and 7. So we do that and we put in 5 for k, 5 squared minus 5 plus 1 equals 21, and then 6 squared minus 6 plus 1, which is 31, and then we plug in 7 to get 43. And after doing about 4 problems, you can then identify whether it's arithmetic, or which is adding, geometric, multiplying, or neither. And in this case, it's neither problem. So we have to do a different route, but if it was arithmetic or geometric, then you could use the sum formula to solve the rest. So since there's neither, we have to continue to add, and we're trying to get to the 9th term. We know that because it says it up there. So we keep the numbers we have, and then we plug in 8. 8 squared minus 8 plus 1 is 57. And then 9 squared minus 9 plus 1 is 73. So now we're going to add all of these together. So 13 plus 21 plus 31 plus 43 plus 57 plus 73. When we add all this together, you get the final answer of 238. So example problem number 2 is one of those problems where you're trying to find a specific term. In this case, we're trying to find the 5th term in the sequence, and they will give you the a sub 1 typically, and then the formula a sub n equals 2 a sub n minus 1 minus 4. So this is pretty easy. You're just going to plug in a sub 1 into that formula, and you calculate out a sub 2, which is going to be 18, 11, 2 times 11 minus 4. And then you keep going. You're going to then plug in that 18 into the a sub 1 to get a sub 3. So 2 times 18 minus 4 is 32. And then you take the 32 and plug it in, and just keep repeating that all the way until you get to the fifth one, and you'll get 2 times 60 minus 4, which is 116, which is the answer. And the third type of problem, it says find the sum of the first 10 terms within the sequence, and it gives you -4, 28, and -196. So for these problems, you want to first identify whether it's arithmetic or geometric and how much of a change it is. So what's the R in this problem? And you can tell it's geometric just by looking at it. It's multiplying by -7 each time. So then you're just going to go right to your sum formula here at the bottom. This formula right here, S of n equals a sub 1 times 1 minus r to the power of n divided by 1 minus r. And again, that formula is given to you. So you just plug in all your what you're given. So -4 times 1 minus the r, which is -7 because it's multiplying by -7 each time, to the power of 10 because we're trying to find the 10th term. Then divide that by 1 times the r, or minus the r, which is -7, and you should get 141,237,624.